Warning, the video you're about to watch contains mathematics at the level of integral calculus, also known as Calc 2. All material has an assumed prerequisite of differential calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This example is meant for students who are in integral calculus and who are going through trig subs, or maybe just integration techniques in general. The point of this example is to let you know that you should not always dive into a newest method when you're handed an integral that might fit other methods. For example, this guy right here, a lot of people will look at this and think trig sub because you have a difference of squares here. This looks like a 1 minus sine squared, sort of. I mean, it's not exactly, obviously, but it looks something like that. So a lot of students will make an initial substitution to say, let x squared equal 25 sine squared of theta. And of course, taking the square root of both sides, that will imply that x is equal to 5 times the sine of theta. Again, as I've said in previous videos, that if you're taking the square root of both sides, normally you would get a plus or minus. However, because of our choice for x, which is x equals 5, even if it's plus or minus, it's x equals plus or minus 5 sine of theta, that's fine. When you solve for theta, that will imply that theta is equal to sine inverse of x over 5. The critical piece to note here is that inverse trig functions like the sine are range restricted. In other words, the angles that come out of the sine inverse are going to be between negative pi over 2 and positive pi over 2. The point of this is that the angles that the sine inverse return land in either quadrants 4 or 1. Sine is negative in quadrant 4, it's positive in quadrant 1. So the plus or minus that you'd normally get here, that's going to be just folded into the fact that that sine function can actually be negative or positive. So that will hold the plus or minus sign for us. We go ahead and do one final step here, take the differential of both sides. And now we go and substitute that stuff in. Once you get down to here, you can actually factor out the 5, the 125, and the square root of 25. And we know that the square root of 1 minus sine squared is the same thing as the square root of cosine squared. And I have a video on this I just recorded and posted on YouTube, but the square root of cosine squared, because of our choice for x, or for our substitution for x, the square root of cosine squared normally would return the absolute value of the cosine. However, these angles that we're using here are restricted. Specifically, they're restricted to be between negative pi over 2 and positive pi over 2. In other words, quadrants 4 or 1. Well, the square root of cosine squared normally would return the absolute value of cosine, but cosine is positive in both quadrants 1 and 4, and that's where our angle is going to be. So therefore, we don't need the absolute value on this result. Again, this would normally result in absolute value of cosine of theta if you took the square root of a square. But because we know the angles return into quadrants 1 or 4, and cosine is not negative in either of those quadrants, we can just remove those absolute values. Cleaning this up, we have this beautiful result, and now we can go ahead and do a substitution here. So here's a trig sub with another sub, right? I'm going to let u equal the cosine, so it steals away 1 power of the sine. As I've mentioned to my students in the substitution material, when we're talking about substitutions in integrals involving trig functions, that you really want to target to get all the powers to even powers if you can. And a u substitution of cosine means that du will steal away a power of the sine, and in this case, stealing away a power of the sine means that we'll have an even power of sine left over, which is ideal. And that's our result so far. So again, the cosine squared becomes a u squared. The sine of theta in d theta, a power of sine of theta, and then the d theta, gets stolen away for a negative du. So I wrote the negative out front there. And we're left with a sine squared of theta at the end, but we know that sine squared is the same thing as 1 minus the cosine squared. So we can make our substitution, again, not another substitution, but resub in what u is equal to. It's equal to the cosine, so that will be a 1 minus u squared times u squared. Distributing. And notice that when I distributed, I went ahead and took this negative and distributed that in as well. I just dislike a negative in a problem. If I can avoid it, I will. And then the antiderivative. Now, when you get to this point, remember, we did not start this problem in the world of u's, so we're gonna have to trade those out. Well, u is equal to the cosine, so we'll go ahead and do that first. But again, after that, we did not start in the world of thetas either. This problem started actually in the world of x. So I'm gonna go ahead and go to the original substitution, and off to the right-hand side, I'll draw a triangle for the fact that we have x over 5 is equal to the sine of theta. So I'll draw a nice little triangle here. I always draw my triangles as if they're in quadrant 1. That does not mean they're in quadrant 1. It just is a decent, easy triangle to draw. Opposite over hypotenuse is what the sine is, and so the adjacent side is the square root of 25 minus x squared. Now we know the cosine of theta will be the square root of 25 minus x squared over 5. Going down to our problem here, I know all those cosines, or at least both of those cosines, can be traded out for the square root of 25 minus x squared over 5. And this can actually be cleaned up. The reason why it can be cleaned up is that this 3125 out front is actually 5 to the 5th power. And so if I distribute that through, this actually cleans up very nicely to this. Not too bad. It's not like a terrible problem doing a trig sub here, but there is actually a better way. And that's the point of this problem, is that you don't want to just dive into a problem without using any type of thought. Think about the problem first and list out the tactics. You don't have to list out every single tactic. If something's obviously not going to work, don't list it out. For example, if I look at the integral over to the right here, I know that I'm not going to list out direct integration because I don't know the direct integral of this or the antiderivative of this offhand. But I will write u substitution. And the moment that I write u sub in there, it makes me want to go ahead and try it. And in this case, I will. I'll do a nice, unique style of u substitution. I'm going to let u squared equal 25 minus x squared. If you've never seen this style of substitution, you might be wondering what I was doing. What I'm doing is basically saying let u equal the square root of 25 minus x squared. And then I squared both sides. And the reason why I do that is because I can take the derivative or the differential of both sides of this statement. I can do that implicitly. That is, 2u du is going to equal a negative 2x dx. You can divide both sides by 2. Actually, I'm going to divide both sides by a negative as well. When you get to that point, you can see x dx will be traded out for a negative u du. And I happen to have a power of x and dx to do that trade with. So our integral becomes, well, I'll steal away a power off of the x. And that power combined with the dx will be traded out for a negative u du. Also, that square root of 25 minus x squared, that's just u. And notice how clean this is already. And then all we need is a relationship between x and u to trade out x squared. And this is our relationship right here. X squared is the same thing as 25 minus u squared. So I'm going to make that substitution in here. I'm going to distribute that negative through and also distribute the u squared and integrate. Finally, resubstitute back in what u is equal to. U is equal to the half power of 25 minus x squared. And there we have it. Notice that answer matches identically to the answer we did with trig subs, but look, the amount of work required is completely different. The u substitution took a lot less work. And this is why I say do not get married to the idea of using trig substitutions all the time. They are nice, but not always. So if you can do a simple u sub, please do. That's the whole point of this example, is to illustrate that always look at other tactics first. Specifically, u substitution is one of your simplest tactics. That is usually the easiest if it can be performed. All right, I hope this video helped you out, and I hope to see you in a future video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at ease. Says, listen close, don't talk too much, that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.